This video is going to be using Python, but it should be easily adaptable to any reasonable programming language. I'll even be showing on the screen some translations for C++. There will also be a link in the description to a GitHub repository with all the code you'll see in this video. So, you want to write a frick interpreter? Alright, so first let's go over Brainf itself. So, it's a language with 8 instructions, or 7 if you count the square brackets as 1. And it operates on a tape where you can only ever look at one cell at a time. As for the instructions, plus adds 1 to the current cell, minus subtracts 1 from the current cell, greater than moves the program to the next cell, less than moves the program to the previous cell, period prints out the value of the current cell as a character, comma takes a character from the user and stores it into the current cell as a number. Converting from number to character and back is done using the ASCII table. For example, the capital letter A corresponds to the number 65, and B comes right after, with number 66. In fact, the capital letters are all next to each other. But the ASCII table also contains other characters, like the exclamation mark, and even the character for the number 1 has a space in the table. And finally, the square brackets form a while loop that keeps going as long as by the end of the loop, the current cell has any value except 0. The program ends when it reaches the end of the instructions. Also to note, this version of Brainf has wrapping cells, so adding to a cell that contains 255 makes it go back to 0, and subtracting from 1 with 0 makes it go up to 255, so that each cell corresponds to 1 byte of memory. Right off the bat, what are we going to need to run a Brainf program? Well, we're going to need to store the tape. We can just use a list for that. We'll also need to know what cell the program is currently looking at, which can just be that cell's index in the tape. And then, to know where we are in the program, we can just have an index into it, called the instruction pointer, or IP for short. Now, where do we go from here? Well, let's start by writing an interpreter for a simpler language, Deadfish. Deadfish only has 4 instructions and can operate on only a single number, the accumulator, which starts at 0. The instructions are I, which adds 1 to the accumulator, D, which subtracts 1 from the accumulator, S, which squares the accumulator, and O, which prints the accumulator. After each instruction, the program resets the accumulator to 0 if it is exactly 256 or -1. So this program would go up 2, print, go down 3 and get reset, print, then add 1, square, print, add 1, square, print, add 1, square, print, and end up with 2, 0, 1, 4, and 25. For the interpreter, let's first take the program from user input. It's simple that way. And now, what are we going to need to run a Deadfish program? To start, there's the accumulator. And that's it. We don't need to store where we are in the program, since unlike in Brainf, Deadfish programs don't have any form of control flow. So we can just go through the program with a for loop. If it's an I, add 1. If it's a D, subtract 1. If it's an S, square. And if it's an O, print. Finally, if it's 256 or -1, back to 0 it goes. Now, let's test it out. And sure enough, it works. But we won't be able to use this technique for Brainf, as it does have control flow. So, to make a version that could be adapted to brain flippers, we'll need to change it to a while loop that fetches the instruction at the IP and then moves to the next instruction at the end of the loop. The IP, of course, has to start at the beginning of the program. The loop then ends when we reach the end of the program. Perfect. Now, running the Deadfish Hello World program, well, it gives us the numbers corresponding to the characters on Hello World. Better than nothing, I guess. Now, let's use this as a base for our Brainfrog interpreter. Instead of the accumulator, we'll have the tape starting with just one cell, and then the current cell starting at index 0. Let's start over with the instructions and move this to later in the program. So plus is going to add 1 to the current cell, and since these cells are going to wrap around, let's add it a check that can set it back to 0. Same thing for minus, except for subtracting and wrapping around the other way instead. Less than is pretty simple. It just moves the cell the program is looking at back 1 by changing the index. More than does the same in the other direction, but with an added check that adds a new cell if we've gone past the end. Essentially, in this version of Brainf, the tape extends as far as it needs to the right, but not the left. For the period, all we have to do is get the current cell's value, change it into character, and print it. This is done using the cur function, which is based off of the ASCII table I mentioned earlier. Also, notice how we're using end equals empty string to tell Python we don't want it to print each character on its own line. Otherwise, hello world would look like this. For the comma, it's a little more complicated, as we want to be able to take a full line of user input and feed it into the program in pieces, one character each time the program runs the comma instruction. So we're going to set up a list where we'll be saving the individual characters the program still has to take as input. And then when it requests input, we simply have to pop a character from the front of the list, turn it into a number, and store it in the current cell. The ORD function here is just the opposite of the cur function. And then to actually take the user input, we just have to check for when the list is empty to then get the user input, turn it into a list, and save it. We're also going to add a new line to the end of the user input, as most of the longer Brainf programs assume the input ends with a new line. Now on to the tricky part, the brackets. We're going to be implementing each as its own character for simplicity's sake. We're going to do that the opening square bracket makes the program jump to right after the corresponding closing one if the current cell's value is 0 to end the loop, and that the closing square bracket makes the program jump back to right after the corresponding opening one if the current cell's value is not 0 to start the loop again. So we'll need to find all these pairs of brackets, and one of the easiest ways of doing that is by finding them all ahead of time and storing them in a table. For this, we're going to need a stack. Using it, we're going to loop through the code with enumerate to get each instruction and their positions. Then, if it's an opening bracket, we push its position, and if it's a closing one, we pop. Since in a correct Brainf program, all brackets have to match up, this is going to do that each closing bracket will pop the position of its match. Push, push, pop, pop. But after we pop, we're going to have to do something with this pair, and that's store it in a dictionary, the table mentioned not too long ago. We're going to store the position of the opening bracket at the key, which is the position of the closing one, so that when we want to jump back to the beginning of the loop from the end of it, we can just look up in the table the current position in the program, and it's going to give us the position of the opening bracket. But we're also going to need to store the position of the closing bracket at the key, which is the position of the opening one, so that we can also jump from the beginning of the loop straight to the end, in case the loop starts on a cell containing 0. Now to use this table. With the opening bracket, we'll jump to the closing one via the table if the cell is 0. And with the closing bracket, we'll jump to the opening one via the table if the cell is not 0. And now that we're done with the instructions, we can re-add the instruction pointer increment. Notice that in the implementation of both square brackets, we're jumping exactly to the corresponding one, not the instruction after, as we'd said we'd do earlier. But since afterwards we're going to the next instruction anyway, it works out. Phew, I think we're done. And now to run the Hello World program. Hooray! And to test input, here's a simple cat program, which just repeats to the user what they've inputted. Look at that! So now that we've written our interpreter, there's only one thing left to do. Run the deadfish interpreter in Braintrunk in our interpreter. This one takes the deadfish program one character at a time. Simply beautiful. Well, thanks for watching, and remember to check out the code in the link in the description.